Welcome to the Drowsy Science channel, and hello. Thank you so much for being here. Perhaps you simply like to go off to sleep while contemplating stars, galaxies, and the silent secrets of the cosmos, or perhaps it has been a long day. In any case, the trip is for you tonight. You don't have to do anything right now. Simply allow your mind to relax, your body to rest, and your thoughts to wander, since we're studying the universe itself tonight. Not a single star or galaxy, but the enormous, growing whole. We'll learn about dark matter, black holes, distant galaxies, and ancient light as we go from fact to fact. You could be surprised by certain things. Others might linger in your mind like a silent idea just before you fall asleep. Please feel free to like and subscribe if these peaceful investigations aid in your relaxation. It also makes it easier for others to find their way here. If you're prepared, let's get started. We may underestimate the age of the cosmos. The age of the universe is currently estimated to be around 13.8 billion years. This figure is derived from observations of the cosmic microwave background and the rate of expansion of the universe. However, not all approaches are in agreement. Ancient stars and galaxies may be older than that estimate permits, according to certain observations. Others raise doubts about the projected rate of growth or speculate that dark energy might be evolving. The majority of astronomers continue to accept the 13th, since these conflicts have not been settled. 88 figure. However, the question still stands: is the universe older? Did we overlook something essential? What we consider to be the beginning might have been only a single chapter in a more complex and bizarre tale. There are thousands of starless rogue planets cruising the cosmos. Not every planet revolves around a star. Some are totally free, drifting around the cosmos by themselves, with no sun to light their sky or warm them. It's possible that gravitational turmoil caused these rogue planets to be expelled from their star systems after they formed regularly. Others may have developed spontaneously, akin to failed stars. They are frigid, dark, and almost undetectable unless they shine weakly in the infrared or pass in front of background stars. According to astronomers, the Milky Way may contain billions of them, possibly even more than stars. Each one is a universe without sound, a solitary whirl in the immense voids between, adrift in the dark. No sunsets or sunrises, simply a never-ending night punctuated by far-off starlight. It's possible for the cosmos to recycle itself indefinitely. According to the mainstream model of cosmology, the universe started with the Big Bang and may continue to expand indefinitely. An alternative scenario, in which the cosmos experiences cycles of expansion and collapse, is envisioned by certain theories. There is no final crunch or cold fading at the end of the cosmos in these theories. Rather, it resets. It may eventually bounce, slumping inward before bouncing back into a fresh expansion. The old structures could be destroyed with each cycle, although faint remnants of the previous one could be preserved. Though theoretical, these concepts are fascinating. They imply that the universe might simply be a rhythm spanning unfathomable epochs of time, with no real beginning or finish. Repeatedly, one universe gives birth to another. The earliest visible light dates back 380,000 years following the Big Bang. Prior to then, the cosmos was a luminous mist, so hot and thick that light could not move very far before dispersing. However, it reached a turning point as it cooled and expanded. Light was suddenly free to travel, the fog lifted, and atoms formed. We can still see the cosmic microwave background, which is that old light. It is the cosmos's oldest direct signal, originating from the universe itself when it was just starting to turn transparent rather than from stars or galaxies. The expansion of space has caused the photons we see now to travel for almost 13 billion years, stretching into long, chilly microwaves. This light, a soft glow that bears the memory of the universe's first clarity, is subtle yet constant. Nearly all of the planets of some stars are composed of diamond. The chemistry of some solar systems differs greatly from our own. It is possible for a diamond planet to arise if the pressure is high enough and the planet has more carbon than oxygen. At least one such candidate has been found by astronomers. A dense planet circling a pulsar, which is probably the remains of a deceased star. The planet as a whole might be a crystalline form of carbon based on its mass, density, and composition. In essence, a huge diamond. It would not appear like a jewel up close, and it is much too hot to sparkle. Massive carbon lattices, however, could extend for thousands of kilometers beneath the surface. Though uncommon, these bizarre worlds serve as a reminder of the universe's diversity. There are three types of planets: rock, gas, and occasionally crystal. The universe might be infinitely curved with no edge. The idea that the universe has a border that we could reach if we traveled far enough is alluring. However, space doesn't appear to operate in that manner. General relativity holds that the contents of space define its shape. Furthermore, the cosmos may be endless or so big and curved that it circles back on itself, according to recent findings. Theoretically, you could go in a straight line indefinitely and finally end up back where you started if that were the case, by encircling a curved area rather than colliding with a wall. This is comparable to how circling the Earth just reveals the globe rather than an edge. On a much larger scale, the cosmos might operate similarly. Infinite in journey, but not in space. The twin of the Sun might yet be out there. According to some astronomers, our Sun was born with a companion star that formed from the same gas and dust cloud more than 4 billion years ago. There is no reason to believe that our Sun was an exception to the rule that stars form partners. This lost sibling would have long since drifted away if it had existed, being drawn apart by the Milky Way's gradual gravitational attraction. It may still be out there, circling the galaxy in a different direction that is currently hidden from our view. Although there isn't any concrete proof, some hypotheses even connect this twin, known as Nemesis, to enigmatic extinction patterns on Earth. Nevertheless, there is a persistent notion that our Sun, which is stable and solitary in our sky, might have previously been born with a quiet companion who has long since disappeared into the stars. The weight of a neutron star raindrop would surpass that of Mount Everest. The collapsing cores of huge stars, extremely dense leftovers left over after supernova explosions, are known as neutron stars. Despite being only 20 kilometers across, they have a mass larger than the Sun. A teaspoon of the substance inside would weigh billions of tons due to its extreme density. A single raindrop made of neutron star material would weigh more than any mountain on the planet. We don't normally encounter such a density. A sort of superfluid neutron soup is created when atoms are squeezed together so closely that protons and electrons combine to make neutrons. Extreme things, neutron stars are small, heavy, black, and spin quickly. However, the memory of star collapse, an ultimate state in which matter becomes almost pure gravity, is stored in their quiescent mass. We can get light from a single galaxy in several different ways. Light doesn't always move in a straight line. For instance, space-time itself is curved in areas of space where gravity is particularly intense, close to huge clusters of galaxies. Similar to how glass bends a beam, this curvature bends the light's course. We refer to it as gravitational lensing. We can occasionally observe distinct perspectives of the same distant galaxy, which is one of its most peculiar effects. These pictures may show up as whole rings, arcs, or smudges. They are duplicates in our eyesight rather than in space, with light traveling through distorted space-time on different routes before reaching our eyes. Astronomers have occasionally seen the same supernova burst more than once because its light came in via distinct gravitational paths. It serves as a subdued reminder that even light can become lost in the universe and still find its way back. It's possible that the Sun was 1,000,000 times brighter than the first stars. The original stars weren't like the ones we see now. These stars, known as population 3 stars, were born from the pure hydrogen and helium that remained after the Big Bang. They most likely formed without any metals at all, which is why they are huge, hot, and short-lived. Some might have had masses hundreds of times greater than the Sun's. After only a few million years, they would have exploded spectacularly after burning through their fuel and shining 1,000,000 times brighter than our own star. Although none of these stars are left today, the universe was altered by their brief existence. They seeded galaxies with light, produced the first heavy elements, and laid the foundation for all subsequent life, including our own. Although their light is no longer present, their traces can still be seen in the silent structure of the early universe and in the chemistry of old gas clouds. While you sleep, dark matter circulates throughout your body. Dark stuff quietly swirls about you while you lie still. It is not a mist that cannot be seen. It is a type of stuff that is incapable of interacting with light, reflecting, emitting, or absorbing it. But it reacts to gravity and has mass. A massive halo of dark matter envelops our galaxy. Trillions of dark matter particles are believed to travel through each square centimeter of your body every second as Earth passes through this halo. Your atoms do not clash with theirs. They are present, ever present, ghostly, and necessary. But they leave no trace. The universe would be substantially different without dark matter because galaxies wouldn't hold together and cosmic structures wouldn't emerge. The composition of dark matter is currently unknown. However, we are aware of this. Even while you're asleep, it's a part of your environment, moving through you constantly and softly. There are galaxies that shine even when they contain no stars. Astronomers have found galaxies that sparkle, yet have very few stars in the quieter regions of the universe. Despite having a lot of gas and dark matter, these spectral systems don't appear to have formed any stars. Violent gravitational collisions may have caused some to lose their stars. Others might never have achieved much stardom. Some are almost invisible outside of specific light wavelengths, extensive scans of the sky with faint smudges. These galaxies cast doubt on our understanding of the formation and evolution of galaxies. Why haven't they created stars if they have a lot of dark matter? Where did they go if they ever had stars? Like forgotten remnants of the cosmos past, these calm, faint systems drift through space. Remember, not all galaxies are blazing with light. Some just float unnoticed and unanswered. There should not be a cold point in the universe. The faint glow of the Big Bang in the cosmic microwave background. A section of the sky is abnormally frigid. It isn't merely marginally cooler than its environment. It's larger and considerably colder than experts had anticipated. The existence of this frigid region, which extends over hundreds of millions of light-years, deviates somewhat from the smooth randomness predicted by early universe physics. Some speculate that it might be the mark of a huge cosmic emptiness. Some speculate that it might allude to something much more bizarre, such as the collision of our universe with another during the early stages of inflation. So far, no explanation is complete. One of cosmology's most subtly disturbing riddles is still the chilly spot. It's a hint that something in our universe might not be what it seems, not a screaming abnormality. The moon is gradually abandoning us. The moon moves towards Earth by about 3.5 centimeters each year. That's approximately how quickly your fingernails grow. Since the moon's formation about 4.5 billion years ago, this gradual retreat has been taking place. A day on Earth was only a few hours long back then, and it was considerably closer. Tidal friction is the cause. A tiny energy transfer causes the moon to progressively push outward in its orbit as it tugs on Earth's seas and the planet rotates beneath them. It's a silent, unrelenting process that is evident over aeons but undetectable on human time spans. It's possible that Earth and the moon will eventually become neatly locked, revealing the same face to one another at all times. For now, while we whirl under its far-off bright light, it simply keeps slipping away little by little. Like dancers in contact, binary stars are able to switch their outer layers. The two stars in certain binary star systems orbit each other so closely that their outer layers start to come into contact. One star may swell and spill matter onto the other as they develop, resulting in a delicate spiraling material exchange. The transmission can occasionally be steady and peaceful. At other times it causes rapid rotation, light bursts, or even a full merger. The image is strangely graceful, yet the mechanics are complicated. Two stars locked in orbit, blending and brushing against each other. One star can become enlarged and wealthy, while the other is stripped to a glowing core. Their destinies are intertwined. These silent touching binaries are the precursors of some of the universe's most peculiar objects, such as certain supernovae or compact neutron star pairings. A reminder that even stars in space are capable of sharing, evolving, and occasionally embracing. Space is not a completely empty vacuum. The universe is never really empty, not even in the farthest, darkest corners of space, far from any star or galaxy. Quantum physics describes the so-called vacuum as a sea of activity. Pairs of tiny particle-antiparticles appear and disappear almost instantly. Everywhere, these quantum fluctuations occur constantly, giving reality a rather erratic backdrop. They have the power to change how particles move, how fields behave, and even how much energy is present in empty space. This contributes to the formation of dark energy, the enigmatic factor that speeds up the universe's expansion. Therefore, the idea that deep space is quiet and motionless is only partially accurate. A dance of probabilities, a covert hum of creation and disappearance, always just beneath the surface of nothing, can be found beneath the silence. Different parts of the universe may experience time moving at varying speeds. Time seems constant to us, like a ticking clock that runs the same for everyone, everywhere. In actuality, however, time is closely related to motion, gravity, and the geometry of space-time itself. Time slows down in areas with great gravity, such as those close to a black hole or a dense galaxy cluster, compared to those with weaker gravity. This goes beyond theory. Atomic clocks, satellites, and experiments have all verified it. However, some cosmologists question if time might change on even greater scales. Could the early expansion of the cosmos cause time to flow slightly differently in different places of the universe? Though hypothetical, the concept creates intriguing possibilities. Even time may not be absolute in a relativistic universe. It can be subtly altered by the area it passes through, bending, slowing, or stretching. There is a hidden halo around the Milky Way that is bigger than the galaxy itself. A luminous spiral is what we see when we see pictures of the Milky Way. Beautiful arms of gas, dust, and stars. However, there is a huge, largely invisible structure surrounding this well-known one, the halo of the galaxy. It is a massive sphere of dark matter and diffuse gas that stretches well beyond the galaxy's visible boundary, reaching lengths many times longer than the disk's own. Ancient star clusters, wayward stars, and enormous amounts of invisible matter can all be found in this halo. It is kept together by gravity, has been molded by past collisions and mergers, and contributes subtly to the stability of the galaxy. We can deduce its existence from the velocity of stars and the bending of light, even if we cannot see it directly. It turns out that the Milky Way is simply the luminous core of a much bigger object, a brilliant heart encircled by unseen arms. A galaxy's light has been detected by us only 200 million years after the Big Bang. There are roughly 13 in the cosmos, 8 billion years old. However, light does not move instantly. It travels across increasing space, slowing and stretching as it goes. Because of this, we can observe galaxies not as they are now, but rather as they were in the past. On the cosmic scale, light from a galaxy that existed only 200 million years after the Big Bang was recently discovered by astronomers using the James Webb Space Telescope. For almost 13.5 billion years, that light has been moving in our direction. The actual galaxy is tiny, dim, and undeveloped. However, it contains hints about the formation of the earlier structures. It's like peering through a small window into a world we weren't supposed to glimpse. The early stages of the universe, when stars were just starting to emerge from the darkness. The universe's large-scale structure resembles a neural network. A startling pattern appears when astronomers chart the locations of galaxies over vast distances. Galaxies are not dispersed at random. Rather, they are grouped together along filamentous filaments that are dotted with cosmic voids and large empty areas. Sometimes referred to as the cosmic web, this interconnected network spans billions of light-years. The structure appears uncannily similar to a neural network, the type seen in the human brain when you zoom out far enough, which is unsettling. Galaxies' filaments are like the axons that connect their dense nodes, which are like neurons. The similarity is simply structural, of course. There is no thought in the universe. Still, it's a quietly lovely thing to think about. Despite being formed by very different physics, the greatest structure we are aware of and the one within your head can end up looking remarkably similar. Stars have the ability to sing through space. We don't hear sound the way we do on Earth because there is no air in space. However, stars continue to produce deep, sluggish vibrations that flow through their internal gases in a manner similar to how seismic waves move through a globe. By monitoring minute variations in the star's brightness or surface motion, scientists can identify the pressure waves that cause the star to pulse and oscillate. The study of this is known as astroseismology, the seismology of stars, literally. Like a fingerprint, the size, structure, and age of each star determine its unique internal frequencies. Scientists are able to observe stars and discover what is going on beneath the surface by listening to these celestial vibrations. It's a form of cosmic echolocation that allows one to hear star music that is inaudible to the human ear over light years. There are stars that are older than their host galaxies. Not all galaxies are created at once. As they develop, they combine with smaller systems and attract gas and stars from other areas. This implies that a galaxy's existing structure may not be as old as some of its stars. It's possible that they originated in smaller galaxies that eventually combined to form a larger one. These old stars frequently reside in globular clusters, which are closely packed groups that orbit far from the galaxy's center or on the periphery. Almost as old as the cosmos itself, some of them are almost 13 billion years old. They bear the chemical imprint of a much younger universe, when only the most basic atoms and fewer heavy elements existed. These stars are silent survivors from before the galaxy joined together completely, somewhat like fossils. They have old light. Their tails predate the formation of most of what we know today. We are not sure why some galaxies do not contain dark matter. The invisible glue that holds galaxies together is believed to be dark matter. It explains why galaxies cluster the way they do and why stars in their outer regions travel more quickly than is predicted. However, astronomers have discovered galaxies that appear to break this law in recent years. Galaxies that exhibit completely non-dark matter behavior. Their stars move as if there were only visible stuff. This finding was surprising because it is difficult to incorporate into existing models. Some physicists believe that previous collisions stripped away the dark matter. Others question whether our understanding of dark matter is complete. In any case, these odd galaxies imply that there are still mysteries in the cosmos, and that our perceptions of what is universal may not be real. Like a gigantic booming bell, the sun rings. Sound waves travel through the plasma deep within the sun, bouncing from one layer to another and causing a slight, constant vibration throughout the entire star. The noises we perceive with our ears are not the same as these waves. They are sluggish, low-pressure waves that are inaudible to humans. However, scientists are able to identify them and use them to investigate the internal structure of the sun thanks to sensitive sensors. Helioseismology is the name of this field. Scientists can track the density, rotation, and even the hidden fluxes of hot gas deep beneath the surface of the Sun by watching how its rings change. In this way, the Sun functions as a large, intricate, and perpetually performing musical instrument. All we need is the appropriate equipment to listen. Additionally, what we hear aids in our understanding of stars worldwide as well as the Sun itself. We cannot see the filaments that galaxies follow. The biggest structures in the cosmos are not composed of gas or stars. Dark matter, an unseen force, shapes them. This dark matter created massive filaments that stretched throughout space over billions of years. And like beads on a thread, galaxies have a tendency to form and travel along these filaments. By examining how galaxies cluster and how light bends as it travels through these areas, scientists may deduce the filaments even if we cannot see them directly. The filaments can link enormous clusters of galaxies and extend over hundreds of millions of light years. Great voids, almost empty spaces with very little matter, are located in between. Galaxies are shaped by the dark matter filaments, which serve as a covert scaffolding for the visible cosmos. We still don't understand what dark matter is, though. The universe is held together by the structure, which is vast, invisible, and silent. It is possible for space to expand more quickly than light. Nothing is faster than light under normal conditions. However, that rule does not apply to space itself. Space expanded so quickly in the early post-Big Bang era that parts of the cosmos were yanked apart more quickly than light could move between them. Motion across space was not what this was. It was the actual extension of space. Faraway galaxies aren't rushing away because they're traveling through space at a high speed even now. The distance between us and them is growing, thus they are moving away. We won't see them again because of that stretching, which causes them to move away faster than light if they are far enough away. It's a subtle effect of how space acts on cosmic scales rather than a breach of physics. There's no need for the universe to hurry. It merely spreads beyond our grasp in a calm and unrelenting manner. Like a helical spiral, our solar system travels across space. The planet's smooth, flat orbits around the Sun are simple to visualize. However, if you zoom out more, a stranger appears. The Sun is in motion, traveling at a speed of around 1 million kilometers per hour around the Milky Way's center. The planets move with it, spiraling through space behind it, rather than merely circling the Sun. A helical pattern like a corkscrew or a twisting ribbon is produced by the combined action. Everything is moving. The Sun, stars, planets, even the galaxy itself. Space is a place of beautiful, unceasing drift, not of rest. We're tracking slow spirals across a moving galaxy while we sleep, encased in layers of orbits inside orbits. We never feel the dance because it is so wide. Everything has a temperature, even nothing. You will be encircled by what appears to be absolute emptiness if you venture far enough into deep cosmic space, away from stars, planets, and galaxies. However, there is a temperature even in the Hoover. It's around 2 degrees there, only a few degrees above absolute zero at 7 Kelvin. The cosmic microwave background is the source of it. Cosmic expansion spanning billions of years has now stretched and cooled the remnant glow from the Big Bang. The universe is filled with this feeble radiation. It is present wherever you go. It is the early universe's silent thermal signature. Still present, still quantifiable, and it will cool even more in the future. The cosmos might get close to absolute zero in a few trillion years, but it will never quite get there, because the echo of heat persists even in the most nothingness. The entire universe might have been fashioned by quantum fluctuations. The universe exhibits unpredictable behavior at the tiniest scales of reality, which are much smaller than atoms. Because quantum physics is inherently uncertain, tiny random fluctuations in energy can appear and disappear in an instant. Furthermore, A number of cosmologists believe that inflation may have enlarged those fleeting, random blips in the early cosmos. The minuscule oscillations were stretched to astronomical dimensions as space expanded at an unfathomable speed. Eventually, those oscillations would become the seeds of structure, the locations where stars would ignite, galaxies would form, and matter would gather together. To put it another way, the galaxy, filaments, voids, and the vast structure of the universe might all be traced back to brief, random occurrences at the tiniest scale. The trembling of nothing gave birth to all we see today. Over millions of years, dying stars can pulse like heartbeats. Not every star has a spectacular demise. Some fade more slowly, and they may pulsate in their last stages, undergoing repetitive cycles of swelling and shrinking. The brightness of these stars, sometimes known as variable stars, varies over time. Sometimes the shifts recur like a slow heartbeat, steady and regular. Changes in the outer layers of stars, where gases expand and cool before collapsing and heating up again, are what generate the pulses. Every few days, certain stars pulse. For others, a cycle takes months or even years to finish. Since the pulsation patterns of these rhythmic stars correspond to their actual brightness, they have been used to calculate distances in space. Additionally, they are silent reminders that stars can still tell time, not with a clock, but with a steady, lingering sigh. Earth is encased in a massive bubble of heated gas that spans cosmic eras. You would discover that our solar system is encased in a huge, incandescent bubble of hot gas if you could see far into the unseen light wavelengths that are beyond what your senses can perceive. It is known as the local bubble, and it extends in all directions for hundreds of light years. Ancient supernovae are believed to have created this bubble by exploding stars that sent shockwaves into the surrounding gas, heating and expelling it. Our solar system now silently moves through this area of low density, which is encircled by a shell of hotter dust and gas. It's not harmful. Even though we can't feel it, it exists. Around us, there is a sort of peaceful chamber that was created by violence in the past and is now a part of the serene surroundings of our galaxy. Behind the Great Attractor lies a huge area of emptiness. Our own Milky Way and other galaxy clusters are progressively drifting towards the Great Attractor, a mystery gravitational anomaly that is so huge in space. However, something more odd lurks beneath this massive concentration of stuff. A region where space seems abnormally empty, called the dipole repeller. There is more to it than an area of fewer galaxies. It is hundreds of millions of light-years of expansive cosmic emptiness. Strangely enough, galaxies appear to be pushed away by its nothingness. Our local universe's velocity is influenced by the silent gravitational tug-of-war produced by the big attractor and the dipole repeller. An unseen mass pulls us forward, and the empty outside pushes us back. It serves as a reminder that our course in the universe can be influenced by both presence and absence. Neutrinos flow through you and the Earth in silence. You will never be aware of the trillions of particles called neutrinos that are currently moving through your body. Extremely light and neutral, neutrinos are created in vast quantities by the Sun, exploding stars, and even the early universe. They hardly ever come into contact with ordinary materials. They are capable of flying undetected through your entire body or a planet. Some go through detectors buried deep down, where we can analyze them thanks to infrequent impacts. Most, however, just go unseen. These particles are constantly present and softly flow across both matter and space. Despite traveling at virtually the speed of light, they seldom ever make contact with objects. Even when it seems like nothing is moving, the universe is constantly in motion. Even the biggest stars can fall straight into black holes without exploding. We frequently envision a cataclysmic supernova as the demise of a huge star, a dazzling explosion that illuminated the galaxy. However, the final moments can be oddly silent for the biggest stars. Because of their extreme weight, some stars collapse inward when their cores run out of fuel, and gravity winds so abruptly and completely that even the outer layers fall in. There was an abrupt vanishing, no dazzling farewell, no explosion. We refer to this process as a direct collapse. A star vanishes in an instant, to be replaced by a black hole that is crushingly dense, silent, and undetectable. Even stars that appear to disappear completely, as though the light has flickered out, have been seen by astronomers. It serves as a reminder that not every cosmic conclusion is spectacular. Some are murmurs in the shadows. Like moons around planets, galaxies can orbit one another. Although many galaxies exist in small groupings where they interact and even orbit one another, we often think of them as solitary islands in space. For instance, there are dozens of smaller satellite galaxies in our own Milky Way. The most well-known are the melanic clouds, both vast and little. These companions slowly follow lengthy elliptical routes through space, orbiting the Milky Way like moons orbit planets. Stars are occasionally separated from their neighbors by larger galaxies, creating tidal tails and streams that span millions of light years. A smaller galaxy might eventually be totally swallowed. Over billions of years, these cosmic dances take place, interactions that are gradual and elegant on a scale that is beyond our comprehension. Even galaxies can keep each other company in the silence of vast space. Magnetic stars that are collapsing produce the brightest explosions in the universe. A magnetar hypernova is a rare type of explosion that could be among the brightest objects the cosmos can create. A neutron star with an unfathomably powerful magnetic field, trillions of times stronger than Earth's, is called a magnetar. A huge star can unleash a flash of light and energy significantly more potent than a normal supernova if it collapses into a magnetar and discharges its energy rapidly. Some long-duration gamma-ray bursts, which are bursts of high-energy light that travel throughout the universe and momentarily outshine entire galaxies, might be caused by these events. The light from the brief explosion can travel billions of light years to reach us. When a small, dense object enveloped in magnetic fire collapses in on itself, it creates one of the most powerful events in the cosmos. The universe's edge is not the edge of the observable universe. There is a limit to how far we can see as we gaze out into space, in either direction, roughly 46 billion light-years. The observable universe ends there. It is just the furthest light has traveled since the Big Bang, given the expansion of space, and is neither a wall nor a limit. The universe probably goes on after that. It's simply not visible to us yet. Additionally, some regions of the cosmos are escaping from us faster than light due to the acceleration of space expansion. That implies that, even in an endless amount of time, their light will never reach us. A bubble of vision is analogous to the observable cosmos. Only the portion of reality that is accessible to us, not its entirety. More stars, more galaxies, perhaps forever after that. For millions of light years, certain galaxies emit plasma jets. A tremendously large black hole is located in the center of many galaxies, and occasionally, not all of the substance vanishes as it falls towards it. Some of it is blasted forth in strong, narrow jets after becoming trapped in magnetic fields. Plasma streams traveling close to the speed of light. These jets can extend for millions of light years, well beyond the boundaries of the host galaxy. They are visible to us as massive lobes that delineate their reach, shining in radio wavelengths. These galaxies are known as radio galaxies, and some of the biggest objects in the cosmos are their jets. It's an odd irony. The areas around black holes where light can hardly escape can produce the strongest outflows. It appears that even silence can have an impact. One star completes a backward orbit around the Milky Way. Following the rotation of the galaxy, the majority of stars in the Milky Way orbit in the same general direction. Not all of them, though. H 04375-439 is the name of at least one known star that travels in the opposite direction. Like a salmon swimming upstream, it cuts against the flow with its retrograde orbit. How did things end up that way? One explanation is that its orbit represents the older, distinct system that existed before it was a part of the smaller galaxy that merged with the Milky Way in the distant past. Alternatively, a gravitational slingshot, possibly from a massive star cluster or black hole, may have sent it into its present course. In any case, it serves as a subdued reminder that not all celebrities are created equal. There are also lone travelers making their own path across the galaxy's huge clockwork. The galaxy's core has a rum and raspberry scent. It's real, even though it sounds like a joke. A molecule known as ethyl formate was found by astronomers examining the chemical makeup of a dust cloud close to the Milky Way's center. It's connected to the taste of raspberries and the aroma of rum on Earth. The galactic center doesn't really smell, of course. The existence of these molecules suggests the intricate organic chemistry taking place in deep space, even though the vacuum of space wouldn't be able to carry scent the way air does. Interstellar clouds contain sugars, alcohols, and even precursors of amino acids. It's the type of chemistry that life would require, but it's not life. Therefore, space includes the building pieces that silently float between the stars, even if it may not smell like fruit and spirits. The Milky Way is already being touched by a galaxy that is directly approaching it. Our closest massive galactic neighbor, the Andromeda Galaxy, is headed for a slow-motion collision with the Milky Way. It is currently around 2.5 million light-years away. However, that disparity is narrowing. The two galaxies will start to combine in roughly 4 billion years. Interestingly, there is already overlap between the two galaxies' outer halos, which are enormous clouds of hot gas and dark matter. Thus, in a way, they have already started to touch. The final merging will be less of a crash and more of a smooth mixing. Most of the time, stars will fly by each other without colliding. The two spirals will eventually merge to form a single, bigger elliptical galaxy. This futuristic system is sometimes referred to as Milka. Although it will take a while, it is already underway. A cosmic encounter that takes place across billions of years. All around you, the cosmic microwave background continues to blaze. The cosmic microwave background is the faint glow that permeates the entire universe, including the area you are now in. It is the Big Bang's afterglow. When the cosmos was roughly 380,000 years old, light was released. The universe was a hot, dense plasma in those days. Light could finally move freely when it cooled sufficiently for atoms to form. Since then, the expansion of space has caused that light to move, stretching into microwaves. These days, we can see it as a nearly constant glow in every direction. Although you cannot see or feel it, sensitive detectors can detect it as a cosmic whisper of sorts. This glow is the oldest visible light, a faint signal from the early days of the cosmos that continues to reverberate throughout time and space. Rather than light, some supernovae are driven by unseen collapse. Known for their brightness, supernovae are enormous explosions that momentarily outshine entire galaxies. However, not every supernova is bright. Some are referred to as failed supernovae by astronomers. In these situations, a black hole is created when the core of a large star collapses. However, there is no visible flash of explosion from the outer layers. Alternatively, they might descend inward, silently supplying the black hole with food. We have occasionally seen stars that appeared stable abruptly disappear from view. Just darkness, no fading glow, no explosion. A collapse so profound that nearly all of the energy is absorbed is suggested by these disappearances. Though much of it is concealed, there is still a great deal of violence. It serves as a reminder that not all deaths in the cosmos are noisy. Some things are silent. Entire galaxies composed primarily of gas and dark matter can be found deep within the grasp of gravity. Galaxies are frequently pictured as luminous ellipticals or dazzling spirals that contain billions of stars. However, some galaxies are hardly perceptible. Although there aren't many stars in these faint systems, they nevertheless have mass, primarily in the form of gas and dark matter. They frequently only show up as weak smudges or by indirect measurements, making them challenging to detect with standard telescopes. Perhaps because they were stripped of gas or heated too early in the universe's history, some of these galaxies are failed systems, structures that never produced many stars. Others might represent transitory stages of galactic development. Subtlety is what unites them all, just a silent gravitational presence without any explosions or spiraling arms. They serve as a reminder that not all galaxies are bright. Some just are. In cosmic dances, black holes can clash and merge. Gravitational waves are ripples in space-time produced when two black holes orbit each other. The black holes spiral inward as energy escapes, eventually merging in a final dramatic moment. The merging of two phantom titans. Although these collisions don't produce light, they do release gravitational wave bursts that are currently detectable on Earth. Einstein's forecast from a century ago was confirmed in 2015 when the first of these signals was seen. We have since found countless more. Each one describes the collision of big objects in distant galaxies in the distant past. These silent, undetectable, but incredibly powerful black hole mergers transform entire solar masses of energy into waves that reverberate throughout the cosmos. And the very fabric of space sings for a time. Some stars fade over billions of years, dying slowly. Not all stars burst into flames at once. Our Sun and other smaller stars perish far more slowly. Their outer layers are released into space as they expand into red giants after burning through their hydrogen fuel. All that's left is a white dwarf, a heated, dense coal. Energy is no longer produced by this residue. It just slowly dissipates away the heat that remains. It can take billions of years for a white dwarf to cool, progressively becoming less apparent until it is no longer observable. A dwarf that is black. However, the cosmos is too young for that to have occurred yet. Somewhere, all the white dwarfs that have ever formed are still shining, slowly dying in the darkness. These stars' demise is more akin to an ember slowly cooling over cosmic time than a fireworks display. In comparison to Earth, time slows considerably near a black hole. According to Einstein's general theory of relativity, gravity bends space and time in addition to pulling on matter. Time flows more slowly in regions with a stronger gravitational field than in those with a weaker one. This effect gets spectacular in the vicinity of a black hole where gravity is extremely strong. Time would move considerably more slowly for you than for someone far away if you were orbiting just outside the event horizon. Years away could be represented by minutes spent close to the black hole. Science fiction is not what this is. Gravitational time dilation is an actual, quantifiable phenomenon. With GPS satellites orbiting black holes, we've even seen it in a milder form. In a sense, it becomes profound. They are more than just light traps. They extend time itself. No lab on Earth is as cold as the space between galaxies. The enormous voids between galaxies are remarkably frigid, far from planets, stars, or even gas clouds. There, the temperature falls to around 2 degrees above absolute zero, 7 degrees Celsius. It's colder than any natural setting on Earth, and colder than the majority of the conditions we can produce, even in highly developed labs. The almost complete lack of particles and energy is what causes this chill. Only a sprinkling of stray atoms and the faint microwave glow of the early universe remain, with nothing to retain heat. The quietest, most isolated places we are aware of are these cosmic voids, huge and desolate, spanning millions of light years. Only the faint murmur of creation may be heard in the deepest darkness of the universe. As the cosmos ages, it becomes increasingly transparent. Light could not move freely in the early universe. A heated plasma, a mist of free electrons and atomic nuclei that continuously scattered photons, engulfed the universe. However, the cosmos eventually reached a point where electrons and nuclei joined to create neutral atoms as it cooled and expanded. Light could suddenly travel freely. About 380 years after the Big Bang, an event known as recombination occurred, releasing the cosmic microwave background that we can still see today. The universe has been becoming more transparent ever since. New light pockets were created by the development of galaxies and stars, and as matter disperses, there is less and less to obstruct a photon's passage. The darkness has grown more apparent over time. Once luminous and impenetrable, space now allows light to flow through it nearly unhindered. We have captured a black hole's shadow. The first direct photograph of a black hole, or rather its shadow, was published by the Event Horizon Telescope in 2019. Although the black hole itself is invisible, its presence is indicated by the luminous ring of hot gas that circles it. This specific black hole is located 53 million light-years away in the center of the galaxy M87. The image displays a circular silhouette, the area from which no light can escape, encircled by a gravitationally warped ring of radiation. Coordination of telescopes worldwide to function as a single planet-sized lens required years of international cooperation. There was more to the outcome than just a photograph. We got our first look at one of the universe's most enigmatic objects in a modest scientific success. Not with theory or fiction, but with light. From your backyard, a galaxy is visible to the unaided eye. The majority of galaxies are so far that only faint smudges can be seen with even the most powerful telescopes. However, you can see one without any kind of apparatus. The galaxy Andromeda. It is visible to the naked eye as a faint, hazy oval in the sky on clear, dark evenings in the northern hemisphere. The light you see started its trip more than 2.5 million light-years ago, which means it predates the evolution of mankind. Andromeda is slowly approaching us and has 1 trillion stars, more than twice as many as the Milky Way. It's difficult to comprehend, but with just the sky, your eyes, and the faint glimmer of something big and old floating in the dark, you can gaze up and see a complete galaxy without the use of a telescope or filter. The faint sound of a black hole collision in the distance was picked up by one small satellite. A tiny satellite called LIGO made an unusual discovery in 2015. Over 1 billion light-years away, a slight rippling in space-time. It was brought on by the collision of 2 black holes, which sent gravitational waves through space. These waves are very delicate. They compress and stretch space by less than a proton's breadth when they get to Earth. But we can find them using sensitive tools. LIGO and its companion observatories listen to the deepest rumblings in the universe, like cosmic ears. Au pair was proof that even in the quiet of space, enormous events may produce waves, as Einstein had predicted a century before. On a peaceful corner of a small blue planet, a tiny detector detects a single chirp from the merger of invisible titans. There are parts of the cosmos that are permanently growing away from us. The cosmos is getting bigger, and as space expands at an ever-increasing rate, so does that expansion. We will never see the light from some galaxies because they are being driven away so quickly. The distance between us and those galaxies would increase too rapidly for the light to bridge, even if we waited indefinitely. They have already slipped over the cosmic event horizon, past the point of no return. The universe will eventually disappear from view in greater and greater measure. Not because it is no longer there, but rather because we are unable to see its light. Although we won't see this right away, it indicates that the visible universe will contract over billions of years. The universe is not merely expanding, and it's letting go peacefully. It's possible that certain black holes existed before stars. The majority of black holes are created when big stars collapse. However, there is an alternative. Black holes that were created before stars were ever present in the early cosmos. We refer to these as primordial black holes. They might have originated from minute oscillations in the hot, dense areas immediately following the Big Bang, as stuff was drawn together into extremely compact knots by gravity. It is possible that some of these black holes are really tiny. Some may have developed over time. Although we haven't found one yet, if they exist, they might provide new information about the early universe, explain dark matter, or perhaps seed the birth of galaxies. They would be silent remnants of the first moments after time began, older than galaxies and stars. Distant regions of the universe may be connected by entangled particles. In physics, quantum entanglement is among the most peculiar occurrences. No matter how far apart two particles are, their properties are still connected when they are entangled. Even at great distances, if you adjust one, the other changes immediately. It implies that reality at the quantum level is intricately linked, but it cannot carry information faster than light. According to some physicists, entanglement may be a part of space-time itself, possibly even holding space together. Theoretically, particles formed in the early universe might still be spread over the expanding universe and entangled now. If so, the void between galaxies might still contain faint, imperceptible links that link far-off areas, quantum echoes from the dawn of time. There is quantum pressure in the space vacuum. Energy exists even in a complete vacuum, which is devoid of atoms, particles, and radiation. Empty space isn't really empty, according to quantum physics. Rather, it is full of little agitated oscillations. Fields are altering slightly. Particles and antiparticles are coming and going, and everything is moving. Vacuum energy is the pressure created by this operation. This pressure could contribute to the explanation of dark energy, the force responsible for the universe's accelerated expansion on a massive scale. Vacuum energy does not weaken with increasing space, in contrast to other types of energy. It remains constant, expanding space more quickly the more of it there is. The idea that the more nothing you have, the more something it becomes, is an odd one. The universe might be torn apart by the silent might of empty space. Over trillions of years, black holes emit a little amount of heat. Known for their darkness, black holes are so dense that nothing can escape their gravitational pull, not even light. However, we are aware that they are not entirely silent because of physicist Stephen Hawking. Hawking radiation is a faint glow that black holes can emanate, according to quantum theory. Occasionally, virtual particle pairings cause one particle to escape, while the other falls in near the event horizon's edge. A small amount of energy is lost from the black hole, and the departing particle becomes actual. This sluggish leaking has the potential to cause the black hole to diminish and finally evaporate entirely over extraordinarily long time scales. That process would take over a trillion years for a black hole the size of the Sun. It ends quietly, with a long, slow fade into nothing rather than an explosion. There is more plasma in the universe than solid substance. Solids, liquids, and gases are often what come to mind when we think about matter. Plasma, on the other hand, is the most prevalent state of matter in the universe. Ionized gas, or plasma, is a cloud of particles with free-moving electrons and nuclei. Stars, the solar wind, interstellar space, and even the immense spaces between galaxies contain it. This is the state of the majority of the universe's visible matter. Compared to other types of matter, plasma behaves differently. It can transport electrical currents over great distances, flows like fluid, and reacts to magnetic fields. Outside of fire, lightning, or neon lights, we hardly ever see it on Earth. However, plasma is present everywhere in space, where it flows, glows, and shapes a large portion of our visual perception. Gravitational waves move at the speed of light, even while we are unaware of it. Gravity has the ability to ripple in addition to pulling. Waves travel through the fabric of space-time itself when large objects meet, like neutron stars or black holes. As they go outward in all directions, these gravitational waves compress and stretch space. and they move at the speed of light, which is the universe's fastest potential speed. The development of tools sensitive enough to detect them took decades. However, these cosmic waves are now audible from Earth. Every wave conveys details on far-off apocalypses, the amount of mass involved, the object's spin speed, and even how distorted space got. Although we cannot hear them, gravitational waves are real, quantifiable, and remarkably mild. Tiny shutters in the universe's underlying structure. Galaxies throughout the cosmos are connected by the cosmic web. You would discover something stunning if you were able to map the locations of galaxies on the biggest scale imaginable. The cosmic web is a huge, linked network of filaments and gaps. Galaxies are not isolated objects in space. They congregate along invisible tendrils of gas and dark matter that run between clusters. Superclusters, which are massive knots of galaxies, are found when filaments converge. There are vast, silent, nearly empty spaces between them. Large-scale sky surveys reveal the structure of the cosmic web, which is not something we can view with a telescope all at once. It looks like a network, a foam, or even the way neurons shoot out. It is the largest size representation of the universe's shape. It is braided rather than random, like something that has grown rather than been constructed. Galaxies that are no longer in existence can be seen with the James Webb Telescope. The James Webb Space Telescope views farther back in time because it was designed to look farther than ever before. We see faraway galaxies as they were billions of years ago because light travels slowly. It is possible that some of the galaxies that Webb sees are no longer there in their current form. They might have faded, merged, or undergone complete alteration. However, even after the source has changed, their light continues to arrive, a moment captured in time, and continues to travel across space. One of the subtle peculiarities of astronomy is this. We can't see what's out there now with telescopes. They allow us to see what existed at various points in the universe's history. Additionally, each deep field photograph is a gallery of lost light and a time machine. The light that departed distant galaxies before Earth existed is what gives them their shine. You can observe age in addition to distance when you gaze at a galaxy located a few billion light-years away. Long before Earth existed, before the Sun formed, and before our solar system had even started to take shape, the light from that galaxy started its voyage. Over 10 billion years ago, some of the galaxies that we see now began to emit light. Eventually, that glow reached our telescopes after stretching and raining as it traveled across expanding space. We are essentially witnessing the ancient history of the universe in real time. It's possible that the stars in those galaxies are long gone. Their light continues to serve as a gentle reminder that there are tails in the night sky that are older than the Earth. Dust clouds can obscure entire galaxies. Dust can conceal even something as large as a galaxy. The light behind them is obscured in some parts of space by dense clouds of interstellar dust. The dust on a bookcase is not the same as this dust. It is composed of silicates and small carbon grains that are floating through icy molecular clouds. A galaxy may have a large portion of its visible light blocked when it is hidden behind one of these clouds. Only when we use specialized equipment to look at infrared, radio, or X-ray light, which can more easily pass through dust, can we detect it. This is how astronomers have found entire galaxies hiding behind what appeared to be a blank sky. Appearances can be deceiving, even in space. Absence is not necessarily implied by darkness. Waiting to be viewed in the proper light is sometimes all that is required. Perfect circles of lensed light encircle some galaxies. Light from much farther away can occasionally be bent by a galaxy's gravity. This bending produces a complete circle of warped light known as an Einstein ring if the alignment is precisely correct. The foreground galaxy's mass bends spacetime, acting as a lens for background light in this type of gravitational lensing. Einstein rings are uncommon but exquisite incandescent loops suspended in space that are created by perspective and gravity rather than motion. A supernova, quasar, or even a far-off galaxy could be the source of the light. Astronomers use these rings to map dark matter, quantify galaxy masses, and investigate the early cosmos. The curvature of space itself creates these natural lenses, which are silent, flawless illusions. It's possible that the cosmos is limitless. It's normal to question whether there is a limit to everything or a border somewhere when we gaze up at the stars. Yet recent findings indicate that space may extend indefinitely. Only a limited portion of the observable cosmos is visible to us. Beyond that, however, the universe might go on indefinitely. Just more galaxies, more stars, and more space. No center, no edge. The majority of the cosmos will always be out of our grasp if that is the case. No matter how long we wait or how far we gaze, we will never be able to see it all. An infinite world is characterized by peaceful expanse that extends softly and without end, yet it does not imply limitless possibilities. Earth is hit by cosmic rays from deep space. Cosmic rays are high-energy particles that strike our globe once per second. Some are from the Sun, while others are from farther away in the galaxy or even farther away. They are composed of protons, atomic nuclei, and other pieces that have been pushed to extraordinary speeds by black holes, exploding stars, or other unexplained cosmic phenomena. Some make it to the surface, and some even go through you, but the majority are absorbed by the atmosphere or deflected by Earth's magnetic field. In modest quantities, these particles are largely innocuous, yet they serve as a necessary reminder that space is not empty. It is alive with movement, vitality, and unseen messengers from distant happenings. Occasionally, a cosmic ray strikes a detector, revealing a tale that started light years ago. The path of a particle from your sky to a supernova. There might not be anything like what existed prior to the Big Bang. Though it might not make sense, the phrase "before the Big Bang" seems logical. Many cosmological models and general relativity claim that the Big Bang marked the beginning of time. Matter and energy were not the only things created at that time. Additionally, it marked the beginning of time and space as we know them today. It's similar to asking what's north of the North Pole to inquire what came before. While some theories envision a quantum realm where time functions differently or doesn't exist at all, others propose a previous state or universe. However, in the majority of theories, the Big Bang was not an explosion in space before it was a location we could visit, even in our minds. Space was just getting started. Quasars were once mistaken for neighboring stars by astronomers. Quasars resembled faint point-like objects that were nearly identical to regular stars when they were initially found. However, their light did not act as it should have. Their brightness fluctuated in perplexing ways, and their spectra were peculiar. Years passed before it became clear that they were not stars at all. Their centers were quite energetic, and they were far-away galaxies. A super-large black hole, encircled by a spinning disk of hot-falling gas, powers a quasar. Incredibly intense heat and light are produced by the gas, perhaps surpassing the total brightness of the entire galaxy. It took billions of years for the light from the earliest quasars to reach us because they were so far away. Nevertheless, they appeared to be small stars. One of the most brilliant astronomical discoveries was a case of mistaken identity. Our local cluster of galaxies is descending into an obscure area. The Milky Way is a dynamic system. It floats across space in a loose collection known as the local group, which also includes the Andromeda Galaxy and dozens of smaller partners. In turn, this group is heading in the direction of the enormous attractor, a gravitational anomaly. Beyond there, however, is a more enigmatic area, known as the Shapley supercluster, and maybe other areas that are currently obscured by our galaxy's dense plane. Even if we can't see them all yet, these far-off masses exert a pull that we can quantify. Our entire neighborhood seems to be slipping towards a massive, shadow-covered object. We only know that we are slowly approaching it, under the weight of invisible giants. We have no idea what lies there. We live in the brilliant springtime of the universe. The universe is currently ablaze with stars that are forming, burning, and exploding. However, this is only a recent development. There were no stars for the first few 100 million years following the Big Bang. The cosmic evolution process started when the first ones formed in the dark and illuminated their surroundings. Star formation has increased, peaked, and then gradually decreased since then. We now inhabit what could be referred to as a cosmic spring, a period when fewer new stars are formed than previously. Additionally, there will be a lot more in the far future. The last stars will be born one day. The universe will thereafter gradually grow darker. However, it remains alight with fresh starts for the time being. Quiet enough to sleep, bright enough to wander. Stars will cease to form in the far future. Cold gas and gravitationally collapsing hydrogen and helium clouds are necessary for star formation. However, this fuel eventually runs out. It becomes trapped in stars, destroyed by supernovas, or heated to an unusable temperature. The resources galaxies require to create new stars will run out in billions of years. The rest will get old, burn out, and disappear. The suns, then the red dwarfs, then the blue giants, until even the slowest burning embers cool to nothing. The end of the cosmos is not imminent. It will gradually and silently dim. Black holes, white dwarfs, neutron stars, and the quiet of a frigid universe will be all that remains. Still, not tragic. The majority of the universe's matter is invisible. We only glimpse a tiny portion of the universe when we gaze at its stars, galaxies, and nebulae. The vast majority of matter in the universe is dark. Light is neither emitted nor reflected by it. We refer to this unseen material as dark matter, and because of its gravitational pull, we are aware of its existence, even though we have never physically detected it. Galaxies rotate more quickly than they ought to. Unexpectedly, light from far-off objects bends more. Clusters are more cohesive than their apparent mass would suggest. This all points to a hidden mass that is more than 5 times that of regular matter. The universe is shaped by dark matter, which is present everywhere. It is simply invisible to us. It is a silent, unseen structure that supports everything else. Cosmic expansion has extended light from the primordial galaxies. Light doesn't just move, it extends as it passes across space. The expansion of the universe itself is the reason behind this. It also attracts light waves as it expands. From visible light to the infrared, the light that departed the earliest galaxies billions of years ago has been stretched into longer wavelengths. One of the primary methods used by astronomers to calculate time and distance in the universe is a process known as redshift. The light source is older and farther away the more stretched it is. We can now see that ancient light, which has been reddened and softened by the travel, thanks to telescopes like James Webb. What started off as a young star's brightness now appears as a whisper, stretched by space's breath. The cosmos could be a hologram. Some physicists have given serious consideration to the possibility that our 3-dimensional universe is a projection from a deeper 2-dimensional reality, which may sound like science fiction. The holographic principle is the name given to this. It originates from research on black holes, where data on everything that enters appears to be encoded on the surface rather than the black hole's actual volume. According to certain hypotheses, the cosmos may function similarly as a whole. What we think of as depth and space may instead be a mathematical illusion created by data inscribed on a far-off barrier. It's a gentle reminder that reality, even at its most solid, may not be exactly what it seems, but it's not proven and probably won't have an impact on your daily life. At the smallest scale, space can be granular. From the outside, space looks smooth. It remains continuous and empty, even when viewed under a microscope. However, according to some theories of quantum gravity, space itself might be composed of discrete microscopic units, similar to pixels in a digital image or grains. The Planck length, which is roughly 10 to the power of 35 meters, is the smallest scale that can exist. At that level, smoothness might decompose into something more basic, such as spacetime's own granular, frothy texture. We don't currently have the means to observe it or even conduct direct testing. However, if it is true, then everything, stars, galaxies, thoughts, and even sleep, occurs in a cosmos with structure all the way down, rather than in a pristine emptiness. Some stars spin more quickly than blenders in the kitchen. Some stars rotate so quickly that their surfaces blur into a racing blur and their equators protrude outward. This is furthered by neutron stars, which are the dense remains of enormous stars. A millisecond pulsar is a type of pulsar that can spin hundreds of times per second. This indicates that the entire star, a sphere of nuclear matter the size of a metropolis, rotates more quickly than the blade of a blender. Radiation beams from these objects tick with incredible accuracy, sweeping over the sky like cosmic lighthouses. Many of them pull in matter and accelerate because they are trapped in close orbits with companion stars. They are among the oldest clocks in the cosmos and among the fastest known rotators, in the night, ticking silently. A slow, silent fade could be the end of the cosmos. The possibility of the universe collapsing back on itself was previously a concern of cosmologists. However, the evidence now points to a different outcome: slow, unending growth. The night sky will get darker as star formation slows and galaxies move away. One by one, the stars will burn out. Evaporation will occur in black holes. Even matter can deteriorate, and the cosmos will get quieter, colder, and more empty. A condition known as heat death. It's a protracted, gradual decline rather than an abrupt occurrence. The universe will become still over trillions of years as structures disintegrate and energy disperses. Silence is the end rather than fire or ice. A universe that created itself in a whisper and then vanished in a whisper. Stars are blown away by superwinds in some galaxies. Strong winds that carry gas, dust, and even young stars can blow out from the core of some galaxies, particularly those with active black holes or intensive star formation. Material is pushed into intergalactic space by these cosmic superwinds, which can extend for tens of thousands of light years. They are propelled by magnetic fields, radiation, and supernova explosive energy. A galaxy may eventually become red and quiet as a result of these winds removing its star-forming gas. Future generations of stars and planets are also seeded by them as they contribute to the distribution of heavy metals throughout the cosmic web. A galaxy breathes in this manner, absorbing stuff, kindling life, and then releasing its breath into space. The cosmos's distant future is a vast, dark ocean. The universe will appear drastically different in trillions of years. Galaxies will appear to be alone in the dark since they have drifted away so much. The formation of new stars will cease. The stars will burn away. White dwarfs' dim luminescence will eventually dim as well. All that will be left will be dark holes, cold, dispersed remnants, and the faint echo of former light. Black holes will evaporate, and matter itself may disintegrate over unthinkably long time scales. All that will be left will eventually be particles traveling across voids, silent, sluggish, and alone. The heat death of the cosmos is the name given to this scenario. It's hardly an abrupt finale, though. It is a cosmic ocean devoid of wind, waves, and shores, vast, dark, and quiet. We may be surrounded by a vast cosmic emptiness. Clusters of galaxies and vast empty spaces known as voids are found throughout the universe. There is relatively little substance in these voids, which extend over hundreds of millions of light years. According to some scientists, we might currently be inside one of these voids, which is a region that is comparatively underdense in relation to the typical cosmic backdrop. If accurate, it might provide an explanation for some findings, such as the cosmic microwave background's patterns or the universe's pace of expansion. Although living in a void doesn't alter our daily routine, it does suggest that what appears to be emptiness could actually be a part of a much greater structure, the peaceful center of a cosmic bubble, slowly floating through an invisible gravity web. The magnetic fields of magnetars are trillions of times more powerful than those of Earth. One kind of neutron star is a magnetar, which is a city-sized remnant of a collapsed star with an unfathomably strong magnetic field. A compass can be guided by the Earth's magnetic field alone. A magnetar's field is so powerful that it has the power to tear apart matter, deform atomic structures, and delete data thousands of miles away. These fields create flares and bursts of high-intensity radiation while they are there, but they are transient and eventually disintegrate. Even from across the galaxy, Earth can detect a single magnetar flare. Such intensity could not be produced in a lab. They are some of the universe's most extreme objects. Like stars that have dissolved into memory and magnetism, they are dense, silent, and encased in an unseen power. A massive quasar group is the largest known object in the cosmos. A massive structure composed of quasars, the bright centers of far-off active galaxies that stretched more than 4 billion light-years across, was found by scientists in 2013. The size of this structure, known as a huge quasar group, calls into question our conception of cosmic regularity. Current theory states that there should be no structures larger than a certain size, and that the universe should be comparatively smooth on the biggest sizes. However, this theoretical limit is exceeded by this quasar group. Its composition, which consists of dozens of quasars connected over a vast expanse of space, raises the possibility that the early universe may have created more extensive patterns than previously believed. It is still up for debate whether this is a statistical anomaly or a real physical structure. In any case, it serves as a reminder that the cosmos is more intricate and more interconnected than our theories can consistently account for. Space can be twisted into a time funnel by black holes. Light is not the only thing that a black hole traps. Space-time itself is warped by it. Time slows down and space bends inward as you get closer to its event horizon. Time around the black hole seems to crawl to an outside observer. It nearly stops at the very edge. In the geometry of space, this warping produces an object like a funnel. One way, steep and narrow. Every way inside leads to the center, the uniqueness. Time and space appear to switch places as you approach, with inward becoming a direction in time rather than space. There's no turning back. There is more to this twisting of space-time than just metaphor. Gravity has etched its geometry into the very fabric of reality. There are parts of the universe that might never see one another again. Certain regions of the universe are already separating more quickly than light can move because of the expansion and acceleration of the universe. This implies that the light from those areas will never reach us, no matter how long we wait. The opposite is also true. We are unable to communicate with certain locations because the distance between them is growing too great. More and more of the cosmos will eventually become inaccessible. Every galaxy will turn into a solitary island in space, encircled by darkness. The rules of physics are not broken by this. Nothing travels through space more quickly than light. However, space itself has the ability to expand peacefully and unabatedly, permanently dividing one part of the universe from another. Gold is the heaviest element produced in a stellar explosion. In the universe as a whole, as well as in our economy, gold is scarce. A regular star's core cannot produce it. Rather, it forms in the most severe situations, such as neutron star collisions or specific types of supernova. Heavy elements like gold, platinum, and uranium are created when atomic nuclei are smashed together under extreme heat and pressure. After being dispersed throughout space and incorporated into gas clouds, these valuable atoms eventually form new stars, planets, and human beings. A cosmic disaster gave birth to every gold ring and dust particle. Your palm now has a silent trace of violence. Gold is ancient and starry in that sense, in addition to being beautiful. It originated from a universe that uses fire to create treasure. Light moves via the expanding gap between galaxies. Light from far-off galaxies appears to us as it did a long time ago, but it is also stretched by the distance it traveled through. The distance that light must travel increases with the expansion of the cosmos. This indicates that the light is stretched. Its wavelength gets longer and moves closer to the red. We refer to this as cosmological redshift. When the light strikes objects, it doesn't slow down or lose energy. It's just moving through an expanding space. The signal is essentially stretched by the universe as it travels towards us. We see more than just distance or age when we observe distant galaxies. We are seeing the evolution of space since the beginning of light's voyage, a silent chronicle of the universe's constant respiration. The structure of the universe contains sound waves that are frozen in place. Matter and energy were closely bound together in a heated plasma in the early universe, before atoms formed and light could move freely. Similar to sound waves in air, pressure and gravity caused oscillations in the plasma, which rippled in compression and rarefaction. A sort of frozen echo was created when these acoustic waves made an impression on the density of matter. Similar to a standing wave caught in space, we may still observe that echo in the distribution of galaxies today, as well as a preferred separation between pairs of galaxies. Baryon acoustic oscillation is the term used to describe this phenomenon. It's quantifiable, yet subtle. A record of cosmic sound from before the universe became transparent, preserved in fossil form. The structure of what we perceive is subtly shaped by an unflinching wave. Larger galaxies can stealthily devour smaller ones. Galaxies don't simply float on their own throughout the immense timescales of cosmic history. They come into contact, bump against one another, and occasionally eat one another. A small galaxy can be torn apart by gravity if it approaches a larger one too closely. After being drawn into lengthy streams and assimilated into the halo of the larger galaxy, its stars are finally so completely merged that the smaller system is no longer visible. Around the Milky Way, we discovered evidence of these mergers. Stellar streams that were formerly a part of other galaxies are arcing through the sky. We refer to this phenomenon as cosmic cannibalism. However, it is slow and graceful, not aggressive, but unavoidable. Large galaxies develop in this manner over time. By silent consumption, not by construction. Only a ripple in the stars remained when one galaxy consumed another. In the night, some stars flicker like fireflies. Not every star has a constant brightness. Some have rhythmic patterns of pulsing, shimmering, or dimming and brightening. There are numerous reasons why these variable stars fluctuate: eclipsing companions, surface eruptions, or waves of internal pressure. They appear to be gently flickering in the sky from Earth, blinking in a leisurely, star-like cadence. Some take hours to finish their cycle, while others take years. These differences aren't arbitrary. Many of them behave like celestial clocks and are very consistent. They are used by astronomers to calculate distances throughout the cosmos. We can determine a star's distance and even its actual brightness by repeatedly seeing the same flicker. Stars do more than simply burn. They breathe, some of them. Some black holes are lonesome in space. Not every black hole resides at a galaxy's core. Some people wander. A black hole may be hurled away by the recoil of a merger, kicked out of a galaxy during a collision, or ejected from its birthplace by gravitational interactions. After being unleashed, it becomes a renegade item that travels through interplanetary or perhaps intergalactic space in silence. It's challenging to find these roving black holes. Unless they pull on surrounding stars or travel through gas, they don't emit any light. However, they're probably out there, unnoticed and unrestrained, cruising through the dark. They don't have a home, a companion, or an orbit. Only bulk, movement, and the intense gravity of the inward-falling, never-stopping thing. Across the galaxy, even black holes can be kicked. A burst of gravitational waves is released when two black holes merge violently. Not all of those waves, however, are symmetrical. The resulting black hole may experience a sort of recoil, a gravitational kick powerful enough to propel it away at thousands of kilometers per second if the merger delivers more energy in one direction. Some black holes are destined to float around intergalactic space after being thrown completely out of their galaxies. Others form broad, meandering circles. Although they are difficult to detect, astronomers think that kicked black holes do exist. The recollection of their own accident propelled the silent travelers. The correct kind of wave can shift even the universe's most rooted and heavy objects. Some stars are reduced to their naked carbon peel cores. When a star like our Sun dies, its outer layers are lost, leaving behind a white dwarf core. Under the tremendous strain of their own gravity, the carbon that makes up the majority of some white dwarfs may crystallize. That is, certain stars turn into enormous diamonds. These star diamonds, which glow dimly from residual heat, are roughly the size of Earth but much heavier. They continue to light for billions of years until cooling to blackness, but they no longer ignite atoms. Some white dwarfs have even been found to pulse, according to astronomers. It rang much like a bell being struck. A diamond floating in space that cools silently. A crystal of ancient fire that was once a star. The majority of the history of the cosmos is still unwritten. 13. 8. It seems like a long time, billions of years. However, we are only at the beginning of the universe's future if you look at it from trillions of years into the future, not just tomorrow or 1,000,000 years from now. Stars continue to form. Galaxies continue to form. The heat of falling matter continues to shine from black holes. The stars will dim in the far future. The galaxies will separate throughout time, and the cosmos will become quiet and frigid. However, that chapter is not yet complete. We are currently living in a time of light, a fleeting period of prosperity when the universe is a flurry of activity and transformation. The future is even more expansive than the past. For millennia, supernova remains continue to grow. A supernova, a dazzling explosion that can momentarily outshine an entire galaxy, is the result of a big star dying. However, the flash is not the conclusion of the event. For ages or even millennia, the shock wave spreads outward, engulfing everything in its path, including gas and dust. We refer to these growing debris shells as supernova leftovers. Their patterns describe the tail of the explosion, and they shine in visible light, radio, X-ray, and many other wavelengths. Some create tumultuous clouds, while others produce delicate filaments. One such remnant from a blast that was observed on Earth in the year 154 is the Crab Nebula, which is still expanding outward. The gradual exhalations of dead stars that continue to unfold long after the light has gone out are known as supernova remnants. One planet can distort the light from a far-off star. We typically imagine stars, black holes, or galaxies bending light on a vast scale due to gravity. But a planet can do it too. A planet can serve as a miniature gravitational lens, amplifying and distorting the starlight if it passes directly between Earth and a far-off star. We refer to this phenomenon as microlensing. Even in other galaxies, its subtlety and rarity can reveal worlds that would otherwise be invisible. The light flickers, the brightness curves gently, and then all of a sudden a world is exposed. Even though the planet is cold, dark, and invisible, its presence subtly distorts the starlight, and that turn is sufficient to declare, "I'm here." There once was a bright orange light that radiated throughout the universe. The cosmos was a hot, dense plasma that was blazing with intense light in the early days following the Big Bang. But that radiance changed as it cooled and expanded. The first atoms formed, and light was able to move freely when the temperature decreased to about 3,000 degrees Kelvin. The universe would have seemed orange at that precise instant. Instead of the current blue-black darkness, there is a gentle, warm glow that permeates the entire universe. Since then, the universe's expansion has stretched this light into the cosmic microwave background, a faint microwave glow that we can see today. However, a long time ago, the entire universe seemed to blaze orange, as though it were illuminated from within, a silent flame vanishing into eternity. The universe is cooling more slowly in some places than others. The cosmos cools slowly and gently as it expands, much like a huge oven being turned off. However, the pace of cooling varies by region. Heat is retained longer in some places with more substance or trapped light. For instance, heated gas found in galaxy clusters stays warm for billions of years. Other areas are more remote and cool down faster. The formation of structures, the evolution of stars, and the duration of specific processes are all impacted by these temperature variations. There are local variances, warmer regions, slower fading, and minor delays in the grand unfolding even in a cosmos with straightforward laws. The universe is not a machine that cools. It is irregular, textured, and silently living, and it cools like weather. One day we might witness the creation of a brand new universe. According to some cosmological ideas, black holes, quantum fluctuations, or other forces that we do not yet fully comprehend could create new worlds within our own. If this were to happen, it would probably happen far away from us, out of our line of sight. Theoretically, however, we could be able to see the signs, a sudden growing bubble of new physics ripping away from our familiar world. We are unsure if this has ever occurred. We're not sure if it ever will. However, there is still hope that something new might emerge from the silent blackness of our cosmos at some point. A whisper inside a quiet, a beginning inside an ending. The universe continues to reverberate from its inception. Inflation is the term for the tremendous expansion of the cosmos in the first fraction of a second following the Big Bang. There were waves from that sudden movement. Across space, tiny quantum oscillations extended. In addition to leaving behind echoes, these ripples became the seeds of all future structures, galaxies, stars, and planets. They appear as temperature fluctuations in the cosmic microwave background, and they might eventually be discovered as primordial gravitational waves or subtle, rhythmic pulses in the very fabric of space-time. Like a bell that continues to ring faintly long after the strike, the universe retains the memory of that initial vibration, even though it may appear to be silent now. You are a means for the enormous universe to understand itself. This is possibly the most subtly astounding of all the odd facts in astronomy. Stardust makes you up. Your body's carbon, your bones' calcium, and your blood's iron were all formed in stars, dispersed throughout space and brought together to form life. The universe is a part of you. You are a conscious moment of it. In an otherwise moving, burning, and cooling world, there is a glimmer of awareness. The universe has developed eyes in this way, and it stares back at itself, wonders at itself, and dreams of itself through those eyes. And it continues to dream even as you fall asleep. I appreciate you being here and traveling through space with me. We have traveled great distances, past young galaxies and dying stars, and heard echoes from the beginning of creation, as well as ripples in space-time. You were breathing gently, your thoughts softening, and perhaps you were already asleep somewhere in the midst of it all, in the brightness of old stars, in the hush between galaxies, in the silent shimmer of dust. There is motion and wonder in this cosmos, but there is also quiet. It contains gravity, heat, and light, but it also contains peace. It's really lovely that we can experience peace piece by piece in silence and tranquilly. I hope you have a restful night's sleep, regardless of whether you're completely awake or just straying from your thoughts. I hope you rest like a star on water, and may you carry, even in a small way, the remembrance of a world that shines within you as much as above you. Now is the time to view the following chapter, if you are still awake. And think about subscribing if you want to drift off to more stories like these, conveyed gently and with awe. One drowsy soul at a time, there's always more to discover. Good night. Music, 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 to music, 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 music,